Okay, so again, welcome to this seminar before the summer, today hosted by the SHAIO and the Mentes Network. Mentes is in Spanish, is something like brain network. It's a multidisciplinary network of researchers in the field of energy modeling, some of them with an input-output background. The network is funded by the Ministry of Science and Innovation in Spain and consists of 9 research groups in Spain. The aim of this network is to bring together national research groups that from different methodological approaches work on modeling energy to explore the synergies and complementarities, to support decision making, to promote capacity, and to participate jointly in R&D projects. In this context, it's my pleasure today to introduce the talk of Professor Julia Steinberger. Julia is Professor of Societal Challenges of Climate Change at the University of Lausanne since 2020. Before that, she worked at the University of Leeds and was senior researcher at the Institute of Social Ecology in Vienna. Julia is a world-leading researcher in the areas of ecological economics and industrial ecology, and her research mainly examines the connection between resources use, energy and materials, greenhouse gas emissions, and societal performance, the economic activity and human well-being. Julia is currently working in quantifying the current and historical linkages between resource use and socioeconomic variables, and identifying alternative development pathways to guide the transformation to low carbon societies. She is the recipient of a Leverholm Research Leadership Award for her research project Living Well Within Limits, investigating how universal human well-being might be achieved within planetary boundaries. She is lead author of the IPCC 6 assessment report. She has published over 40 internationally articles in journals including Nature, Climate Change, Nature Sustainability, Environmental Science and Technology, Ecological Economics, Environmental Research Letters, and many others. And we are proud that Julia kindly accepted our invitation to share with us her advance on these topics with the talk today entitled Using Multi-Regional Environmentally Extended Input-Output to Measure Well-Being Within Planetary Limits, Recent Results. So thank you very much, Julia, and the floor is yours. No?
Mute.
Mute.
Julia.
Of course. So thanks so much, Rosa, for this very kind introduction, and thanks to all of you for having me. So I hope that this will not be boring, and I hope you can see the slides. I think that's okay now. So I'll go reasonably quickly. I guess I should just say one thing, which is that I myself, I'm not an input-output, highly advanced specialist, but we use input-output very much in my project. So I want to show you some of the things that we've achieved thanks to it. So this is basically going to tell you a bit about the context and the reasons for doing my project. Hopefully that's interesting to you to have some other concepts and ideas for doing research. And then I'll go into the results. So the talk is sort of going to be half and half, sort of motivation and what we actually did and what that means for going forward. So I should really give full credit to my team. So within the Living Well Within Limits project, Marta Baltrushevitz and Yannick Oswald are, two PhD students whose results I'm going to be showing you, and they're also supervised by Anne Owen. I don't know if you know her, but she's a real input-output guru, and so you might want to invite her for one of your seminars, and also Joel Millward Hopkins, who's a postdoc on the project. So I want to say a few words about the climate context. So I understand that many of you don't work in the domain of environment or ecological economics, so I just want to go through some basics. And I think that it's important to do this because it really motivates this research. So I would say that we have a scientific basis for the climate emergency, which is the IPCC special report on 1.5 degrees. Obviously, the latest report, one of the latest reports, was apparently leaked to the press today, so I'm not citing that. But basically, the goal of the special report on 1.5 degrees is to basically inform policymakers about what they signed up to with the Paris Agreement. The Paris Agreement is typical UN language. It says 1.5 degrees, but under 2 for sure. We aim for 1.5, but we stay within 2 for sure. And so in this context, the policymakers asked the IPCC, what is the difference? What is 1.5 degrees? Is 1.5 degrees too dangerous already? How different is it from 2? So we're currently already at levels of warming of 1.2 degrees above the pre-industrial level. So we measure the level of warming around 1750, that's where our zero is. It's before we really started burning coal. And we're already at 1.2 degrees above that, so we're already well on our way to 1.5 degrees. And this table is sort of a summary of just some of the impacts. Obviously, the report has many more, comparing them at 1.5 and 2 degrees. And I just sort of chose various impacts that are relevant to different aspects of our planetary and social systems. So deadly heat waves are obviously a very big one that would hit once every 5 years. At 1.5 degrees, it would be 14% of the population. At 2 degrees, 37% of the population, 2.6 times worse. The Arctic free from summer ice in the summer, once every 100 years at 1.5 degrees, once every 10 years at 2 degrees, so 10 times worse. Insect species losing 50% of their range, which means at risk of extinction would be 6% of all insect species at 1.5 degrees, 18%, which is huge, at 2 degrees, 3 times worse. And dying coral reefs, we lose 70 to 90% of all coral reefs would be lost at 1.5 degrees. By 2 degrees, they're basically gone completely. So you can tell that we're in a very nonlinear system and that we really have to act, exponentially against an exponential increase is one way to put it. We have to act very, very soon and very fast to avoid what's coming down the line. So in particular, one of the things that I think is not understood enough is that the impacts of climate change, of warming on biodiversity will be devastating. So this is this paper by Warren et al. In Science, which basically looks at the percentage of species at risk of extinction by 2100, depending on the warming level. And you can see if we end up at 3 degrees, which is where we're heading right now, based on current policies, we're at risk of losing a quarter of vertebrates and almost half of all plant and insect species. And there's just no way that human societies that are in any way stable can survive, let alone thrive in that kind of world. So we really need to reduce our emissions. And so, like I said, the Paris Agreement currently takes us, in terms of the commitments of countries, currently takes us above 3 degrees. There are some new commitments that are not yet into law that might take us a bit below 3 degrees, but we're certainly not heading below 2 degrees. We're certainly not heading to 1.5 degrees. And you can see that we're still on this curve of emissions going up despite COVID. So despite the COVID pause, we're still accumulating CO2 in the atmosphere. We've now left the climate of the Holocene. So the Holocene was the past 12,000 years in human history and planetary history, where the planet was in this nice stable range that allowed us to develop agriculture and cities and writing and anything that we would consider civilization. We have left that temperature range, so we are currently heading out of it. And this is a very uncertain and dangerous future, and everything depends upon what we do in the coming decades. Now, one question is, who could possibly have known where we were going? And this is not a scientific plot. It's a plot that predicts the future, right? It's a plot that was published in a report in 1980, so around here. And it shows where we're heading in terms of carbon concentrations in the atmosphere. So atmospheric carbon dioxide concentrations on this side, on the left-hand side, temperature on the right-hand side. They were pretty much bang-on predictions for the carbon dioxide concentrations. Sadly, they were optimistic in terms of the temperature measured, and this was an internal report published by Exxon before they were ExxonMobil. So one of the things to understand here is that we're in a future that was created for us by, I would say, a certain industry, and that they knew very well what kind of future they were pushing us into. Of course, this was an internal memo. Exxon spent the rest of their time spending millions of dollars every year on disinformation, denial, and harassing scientists. But this is very much the context and the motivation for my research, is that we have this sort of stylized plot of what our emissions need to do, is they basically just need to drop. And that the next few years are the most important in our history, and not just this history of, this century or the last couple of hundred years, but the most important, I would say, in the history of our species. This is not a joke. We are in a very, very dangerous and pivotal time. So the implications for research, I would say, is that we need urgent and radical, we need urgent and large-scale action. So something like radical reductions to happen within the next 20 years to get to zero, or very close. And the surest way to do that is to reduce consumption. Reducing consumption does not require as much new technology or infrastructure as increasing and decarbonizing consumption. But till date, there's been very little, in fact, almost no research on how consumption could be reduced while preserving and enhancing well-being. And that's the focus of my research. And this is really the core question in climate mitigation. Can we reduce energy demand and still have good lives? That's the question. So within the living, so this is basically within the Living Well Within Limits project, we basically understood that we needed a new research framework. So a new way to understand the world and to study it. And this is the analytic framework we came up with. So this was a collaboration with Dan O'Neill and William Lamb, where we basically came up with this way of seeing things, that we have biophysical inputs on the left, which are tied to planetary processes. So, and the way we interact with that as societies and economies is through the use of natural resources. In the middle are these provisioning systems. And what we get out of it is social outcomes. And the social outcomes have to do with need satisfiers and well-being that is based on need satisfaction. And what was one of the things that's very important to us is that we study these provisioning systems as integrated social and physical entities. And I'm not going to talk about it very much right now, but it's been one of the most interesting parts of the project. Okay, so my guess is that if not many of you do research on environmental and natural resources, even fewer of you do research on well-being. It's a bit odd, and it's a bit odd for me too. I'm a physicist by training, so it's a bit strange. So I want to tell you a little bit more about how we do research on well-being. Does it even make sense? So, and when you do this kind of research, you sort of have to go back into philosophy. And some of the most interesting and clear philosophical distinctions were already described in ancient Greece. So welcome to ancient Greece, where around 350 before Christ, Aristotle came along and said lots of interesting things. But one of the things he had to say was a view of well-being. And his view of well-being, this is paraphrasing, obviously, well-being for him meant being able to live life as fully as possible and to flourish within one's society. Now, a bit later, Epicurus came on the scene, and he had a different view of the world. And he had a view of well-being that we recognize maybe more in economics, that well-being means achieving the most positive and least negative feelings possible. And this is something that you might recognize if you think about preferences or utility. You might recognize Epicurus' role in that definition. Now, like all good academic disputes, the two camps persist to this day. And if you're on, you have to choose a team. So if you're on Team Epicure, you might view well-being as happiness. It's a very individual perspective. You might measure it as the happiness indicator or as utility. And in terms of the economy, the way you perceive economy is that you might view economic growth very positively, because more income means more consumption in aggregate, means more positive feelings in aggregate. You're basically making the utility function have more to play with. Whereas if you're on Team Aristotle, your view of well-being is going to be very different. You're going to see it as flourishing, It's a very social as opposed to individual perspective. You might measure it using the Human Development Index or a multi-dimensional framework like the Sustainable Development Goals. That's much closer to Aristotle's vision. And the view of the economy is a view of around development. It's the goal of the economy is to support human potential. It's not to grow, certainly not to grow infinitely. And within the Living Well Within Limits project, we definitely defined ourselves as new recruits for Team Aristotle. So we read a bunch of this stuff. We decided we were on Team Aristotle, and then we wrote a couple of papers to help the rest of our communities to come to grips with this. So if you want more details and more exploration of these concepts, I recommend those two papers. Now, of course, if you're an empirical person who likes numbers, which you might do if you are in the input-output community, you might want to know if we can test Aristotle's theory. So can we test whether or not Aristotle's view of this multidimensional flourishing within society as being well-being? So what we do is we're basically using a theory called the Theory of Human Need, developed by Doyle and Guff in their book in published in 1991, where they say these need satisfiers, a finite number of satiable, non-substitutable needs, are the basis of well-being. And we decided to test that using international data. So we're testing whether or not multidimensional need satisfaction is a precondition for well-being using a database that we developed for about 100 countries across the world. And so what we do is we have average life satisfaction on the vertical axis here, which is sort of an indicator, it's actually an indicator of happiness as well. It's a general indicator of well-being. How do you feel about your life? Are you satisfied with your life right now? And we look at this indicator across the world based on how many need satisfiers a country has achieved. And so if a country has achieved 4 need satisfiers, we put it in this bucket. If it has achieved 2, we put it in the 2 bucket, and so on. And this is what the data looks like. And it's really compelling. We were really surprised when we saw it. Basically, the more need satisfiers are achieved, the higher people's life satisfaction is. And these numbers around 7, et cetera, are sort of the highest values you can find across the world. So in this case, we can say that, yes, need satisfaction, the more needs you satisfy, this is really a perspective that validates a multidimensional finite number of satiable human needs. We did the same for physical health, where the result is, if anything, even stronger, but exhibits a saturation. Okay, so then we decided to test Living Well Within Limits, and we decided to test it internationally using Kate Raworth's donut economics. And this is the first case. So in Kate Raworth's framework, you look at planetary boundaries, and you're trying not to cross them. So you want to stay within the donut in terms of not breaking environmental limits. And you also don't want to fall in the middle of the donut, because the middle of the donut represents deprivation in social indicators. So deprivation in need satisfaction in our translation of it. And this is the first case where we're using input-output, but we're using it in our indicators. We basically are using only biophysical indicators that are footprints. So we're depending on the literature and collecting all of these footprinted indicators. And this is an article that was published in 2018 in Nature Sustainability. So we did not do this ourselves, but in terms of developing the indicators, but we were able to use them and bring them together. And this was really what made this work possible, was the fact that researchers around the world had gone to the trouble of doing consumption-based environmental indicators and providing these footprints. And I just got some examples of countries. So this is Germany, but it could be another country as well in Europe, where you see that this is sort of typical. A lot of planetary boundaries are breached, but a lot of social thresholds are achieved, whereas Sri Lanka has the reverse. It has no planetary boundaries breached, but not many social thresholds achieved. There's a lot of red in there. And we can do this for a lot of countries. So we plot them here based on the number of biophysical boundaries they transgress and the number of social thresholds they achieve. And honestly, it's a rather depressing paper, because let's see if we can find Spain on here. Spain is here. Spain is doing reasonably terrible. All 7 of the biophysical boundaries transgressed, I'm afraid, and 8 out of 11 of the social thresholds achieved. So not so bad, but not so great either. Others are doing better. And you can see that the problem is that this is sort of typical. The higher the social thresholds, the more the biophysical boundaries transgressed, and the lower the biophysical boundaries transgressed, the lower the social thresholds achieved. And where we want to be is here, where there's nobody. The neighborhood where everything is terrible, where you have lots of biophysical boundaries transgressed and very little to show for it socially, is also reasonably populated. But where we need to be is very lonely. And so then the rest of the research is about how do we go there from here. So how do we get inside this donut? And it turns out that you might think that macro social factors, including distribution, are very important. And this is the focus of the PhD of Yannick Oswald, who I showed you before. And so this is a paper that was published last year in Nature Energy, large inequality in international and intranational energy footprints between income groups and across consumption categories. We put everything into that title. We made it very descriptive. And of course, the BBC, when they covered it, said, climate change, the rich are to blame. So, you know, you can be as careful as you want, but then the media will always translate your research as they see fit. So what we're doing here is, this is, you know, something that you might really recognize, but I think it's really a beautiful study, and it really takes input-output analysis. It really, I think, exploits a lot of things that people hadn't necessarily done before. So we're measuring energy footprints, so consumption-based, using environmentally extended multi-regional input-output. One thing that I should say that's special about these energy footprints is they're direct energy, not primary energy, because we see that as more of an interesting level to think about for climate change. Primary energy has a lot of waste in it, because about 2/3 of fossil fuels are lost on the way to making electricity, for instance. So final energy is much closer to what would be directly replaced by renewable energy, for instance. So it makes it more interesting to compare. And we do look at different categories of products based on expenditures. So this is something where what Yannick is doing is he's taking energy data from the International Energy Agency, so final energy data for 86 countries, connecting it to multi-regional input-output, and then connecting the outcome from that to income classes for 86 countries. So final demand is being split into products and income classes. So we're stretching the energy footprints in two ways within each country. So it gives us a huge amount of information if you think about it, because we've got the national level for 86 countries, 4 or 5 income classes within each country, and then a huge number of products within those. And we can do all kinds of things. I mean, the first thing to look at is inequality, like we said. So inequality is really interesting. The relationship changes depending on the inequality of the system you're looking at. So what we can say is that energy inequality is usually larger than expenditure inequality. So most countries in the world fall under this curve of equal inequality. Looking at the Gini coefficients, so that's one thing that's interesting to see. Then we can look at the inequality inter and intranationally. Right now, what we're doing across product groups, because what we're doing is we're taking each income class and plotting it along this curve, depending on how much it uses of different types of energy. So you can see the total energy footprint inequality. I should just specify, these are Lorentz curves, where you plot 100%, it's a cumulative resource use versus cumulative population. So you start at 0% of the population uses 0% of the resource. You end up at 100% of the population uses 100% of the resource. If everybody is equal, you're along this blue line of equality, right? That just means everybody across the world is using exactly the same amount of stuff. And the further away you get from this line of equality, the more unequal your distribution is. And you can see that energy use itself is fairly unequal, but that some categories of energy use are massively more unequal than others. And I don't think that this is something that was known at that level, that we could really see this not just within a country, but really internationally across the world. So package holidays, which is where a lot of flight energy goes, that's you can see that that's the most unequal. So this is really travel for leisure. And the other two categories that are more unequal than average are transportation as well. So vehicle fuel is the purple one, and other transport, like, you know, buses, boats, whatever, is the orange one. And then you can see that food and residential energy are slightly less unequal than average. So another thing we can do, because we have this huge resolution in all these dimensions, is that we can map out the energy intensities, which are shown here, of different products, and their income elasticities. So I'm not going to get into the detail of what an income elasticity is, but it's a standard measure in economics that tells you which, if a product is used more or less by rich groups, rich income classes or poor income classes, and we can map these out using probability density functions, because for each of these we have 86 points. So you can see there's quite a spread in a lot of them, but there's still sort of a well-defined, each of these sort of has a different probability density, and you can learn stuff from that, and you can map it across the developed world or versus Europe, developing countries versus Europe. Sorry about the noise. And this allows us to map product categories. And this, I don't think, is information that people had before this study. So we can really map in this quadrant products that are consumed more by rich people. That's the top half of it. So that corresponds to elasticity above 1. And products that are consumed more by poor people, which is the products that are sort of below below this red dotted line. And then to the left, you have products with less energy per dollar spent, so lower energy intensity, or more energy intensity, more energy per dollar spent. And you can see what's really just pops out right away, and which we were not expecting, is that in this quadrant of luxury and high intensity, it's the transport categories are all represented. Household appliances is sort of on the edge, but apart from that, it's all transport categories: vehicle, fuel package, holidays, vehicle purchase, and other transport categories. Whereas in that high energy intensity but basic, so the lower side, which is consumed more by poor people, it's heat and electricity. This is energy use in buildings. So you really have this dichotomy of richer income classes around the world are spending more money, using more energy disproportionately on transport, whereas poor people are really obliged, despite the fact that they don't want to spend money on electricity and heat in the house. Now, that might give you an idea of what to do about policies. So this is not a problem you can grow your way out of. So you really need to put curbs on what is happening in the economy, because the more rich people get, the more they're going to be using this. So you could think that you need measures of taxation regulation. And if you're clever, you would use the revenues from this to invest in low carbon, in efficiency and low carbon generation here. Because buildings, people will not be able, if you're talking about the poorest people, they will not be able to invest in retrofit and renewable energy. So this is something that has to happen in the public sphere in order for things to go well. So those are just some ideas. I'm not going to spend a huge amount of time on this, but Yannick then followed this up by basically using this information by saying what happens if we make distributions more equal. So especially if we make income distribution more equal. So now that he has this data, he has all these parameters, he really knows how the world is working, we can do modeling on the basis of this. And so he has a model where he starts from income distribution, he then uses the results of the input-output studies, the elasticities of demand and the energy intensities, and he models new final energy footprint accounts. He also does some simulation to make sure we're not doing things that are completely crazy within the parameters we have. And the headline result is that if you redistribute income completely globally, the G7, but if you do redistribute income completely, your global energy would go up, but not by a huge amount, by less than 7%. So, okay, so that's already one piece of information. But what happens when you change inequality across the world is where your energy is consumed changes enormously. And what you can see is that as you go from more equal, which is over here, to more unequal, which is over there, you can see that the pink and the orange sort of trade off with each other. And what you see is, so the orange is heat and electricity, so energy use in buildings goes down as your world gets more unequal, because you're basically squeezing poor people out of being able to afford it, whereas your transport goes up. So as your energy use gets more and more unequal, it goes to richer and richer people who are spending it disproportionately on transport. So that's interesting. And one of the things it means, by the way, is that a more equal world would actually be easier to decarbonize, because the building sector is easier to decarbonize and to retrofit to make it low carbon than transport is. Transport is quite hard to decarbonize. So one headline result is maybe prioritize needs rather than greeds at a given level of income if you can. So I also want to show you these results. We used environmentally extended MRIO to study household level energy footprints in places you might not have thought of. So Zambia, Nepal, and Vietnam. This is the PhD of Malta Baltrushevitz. So she's what she's doing is she's connecting the GTAP database with final energy extensions from the IEA and consumer expenditures. So you use all of these together to get a household energy footprint. And what's really interesting is that these countries, Vietnam, Nepal, and Zambia, but other countries around the world that we don't generally study, have absolutely beautiful household expenditure surveys. And what that means is that one can study these household energy footprints in a way that's really interesting to understand what's going on there. So I really recommend it as a topic of research. And then she basically looks at different variables, different living conditions, and she estimates the energy requirements of being well in those countries. So we're looking at well-being here. So just to show the first headline result is that, so these are the sort of average energy footprints per capita in each country, and you can see that most of it is energy use in the house. That's this green category. But then that green category gets divided among lots of different energy types. There's actually a lot of interesting stuff happening there. Whereas the blue is transport. You can see that Vietnam is quite a bit more developed, more prosperous, and has more transport than either Nepal or Zambia. And it's about half of the global average final energy use. So these are very poor countries, because the global average is about 52 gigajoules per capita, and they're all on average below 25. In fact, well below. So these are obviously very energy poor countries compared to the global average. So these show some I'm not. Anyway, Marta will have to explain to me. But these are results for Zambia. They might be per household. I think they're per household, showing based on income decile per household what the energy footprints look like, and you can see that you can learn a lot of things. You can see that, for instance, the lower the income, the more firewood use, and then as the income gets higher, you actually get firewood plus charcoal. You can see that petrol and diesel for transportation only really in the sort of higher income classes, and electricity, which is the pale blue, also generally appears at the higher income classes. Otherwise, it's quite rare. So Marta also looked at well-being outcomes, and one of the things she found, so she basically looked at modern cooking fuels, which are very important, the education of the head of household and their spouse, whether or not there's sufficient food, and whether then this is not very high in any of the countries studied. So we're looking at a fraction of the households who have these characteristics. So it's almost a third in Vietnam, but it's much lower in Nepal and Zambia. If we look at the energy footprints versus the well-being outcomes, this graph is a bit hard to understand, but let me just walk you through it. So we're looking at Nepal. And here, these are all households. These three columns are all households that have achieved all four of the well-being outcomes. But they're at different quartiles. So this is the 25th quartile, this is the mean, and this is the 75th quartile. The red dots correspond to income per capita, whereas the national average is here. So what this means is that you can see that the households that achieve well-being outcomes are distributed across the income classes, that their energy changes with income class, as you might expect. But one of the things that's interesting is that the average energy of achieving well-being is roughly the same, or for the case of Nepal, even smaller than the national average, but the composition changes. So transport is always larger, and housing is always way smaller. So energy use in the residence is always really a lot smaller, and that's partly due to the dominance of electricity. So when you look at what's happening inside that housing energy, having access to electricity really means that households are able to achieve higher well-being levels while also reducing their energy use. So that's really an interesting result. And also, households in extreme poverty have really different energy profiles than ones that do achieve the well-being outcomes. So you can see that households that don't achieve well-being, and I think that this is just energy use within the house, not including transport, etc. You can see that there's a very, very different profile here, where firewood dominates. So you can really see that this translation between solid fuels and modern energy sources makes a huge difference. And this is the kind of thing we can study because we have access to these kinds of databases. We can really study the whole thing together. I just wanted to show you at the very end, I realize I'm probably running out of time, but this is kind of exciting as well as positive. We tried to model a low energy and high well-being future. We're using the Decent Living Energy Framework of Professor Narasimha Rao at Yale University, where he basically connects human needs to sufficient levels of energy services. It's a global model. It takes into account technology improvements, so existing technology, but everybody has access to good technology, equal distribution, and we get lower energy demand levels. And it was published last year in Global Environmental Change. And we're using input-output here because we're using the coefficients. Basically, we know from our previous studies that certain types of consumption from households have a lot of embodied energy. So we can look at direct energy and change that based on technological improvements, but we also know that there's embodied energy. Some of that might change due to industrial improvements, but we want to include both. And we also look at public consumption of schools and hospitals, private consumption of office space and freight and so on. And then we also look at the embodied energy and infrastructure. And this was led by Joel Millward Hopkins. So we're really sort of combining the data and the information we get from input-output with estimates of efficient technologies, with the conditions that exist across the world in terms of climate and demographics and so on. And the result is really sort of easy to summarize. This is we're this little green arrow. So in context, you look at the global final energy, and this is the IEA reference scenario. So this is data from the International Energy Agency, the IEA 2 degrees scenario and the IEA beyond 2 degrees scenario, where it goes down a little bit. This is the Arnold Grubler published the low energy demand scenario, so he got a bit lower. And our model, where basically everybody's needs are met, but at super efficient technology and nobody consumes more than necessary, gets us down to 150 gigajoules, so really low. Basically, our headline conclusion is that the decent living energy for all is achievable at 40% of current energy use despite population growth. But we're really able to say that we've encompassed a lot. We're taking into account all of the upstream and traded energy and supply chains. And I think that that's where I want to leave it. So thank you very much. So I will stop sharing. Where am I?
Thank you very much, Julia, for your excellent work and presentation. I have echo. I don't know if you have.
Yeah. There's a problem with the echo.
Okay. Okay, so now we have some time for questions, for comments of the audience.
I hope it wasn't too strange.
Absolutely.
Absolutely, yes.
And inspiring, of course. I think Bart is raising his hand.
Yes, Bart.
Yeah, okay. Thank you very much. Thanks a lot for the very nice and interesting presentation. I think it was understandable to most of us, given our knowledge. Also, if you are not an environmental economist using input-output tables. So my question is related to the interplay between the planetary boundaries and the let's say socioeconomic boundaries in Kate Raworth's words. So there are many stories, or I think also there's also a lot of scientific evidence that shows that in a country like China, for example, higher consumption levels in Western Europe and in the United States and in Japan, etc., have led to huge reductions in poverty in China. So I wonder if this is also something that you take into account when doing your analysis. So when you say, okay, if we aim for more equality, aren't you afraid, or do you actually investigate this, whether this won't also have implications for the, let's say, economic or socioeconomic boundaries in Raworth's words? Can you tell us a little bit more about that?
Thanks. I think it's a really interesting question, and actually it's one of the directions I want to go in. So if anybody knows about labor footprinting, I would be super interested, because I think that's one of the things we have to understand as well, is, you know, a different based on different we're talking about technological transitions, we're talking about changes in possibly trade patterns, etc. Who's going to do the work where? That's one of the questions, and I think that's also something where input-out could be quite useful, and I hope to be able to include that kind of perspective. In terms of trade relations, I think that there's the way that, you know, there's different countries that have been able to develop themselves in different ways over time, and honestly, there are not that many strategies that are possible. It has to do with having the capacity to do internal investment. And China was able to do that, and then was able to capitalize on the fact that it had educated but lower cost labor power. But they did do that investment themselves. Now, one of the things that's a problematic in the way our current international setup is, that really needs to be addressed first, I think, is that we have this vision that we are sending money overseas based on our consumption. But the reality is that European countries and the US and Canada and so on are extracting money from countries that are developing through debt relations. So if you look at the net exchange, we are sucking out money from their economies that they could be using to develop themselves, to create infrastructure, to supply sanitation, education, and all the things that they need in those countries. So I think we really need to understand them. I think we have a certain image in our head, but the reality is actually different, that we are the wealth extractors and we are not the wealth creators. And from that perspective, those countries would be much better off if we, you know, didn't necessarily consume anything from them, but at least canceled their debt. Like, let's give them a chance here, because right now they don't have a chance to invest anything because they're under these really punitive structural adjustment programs and debt relations with the rest of the world. And I'm not a specialist in this. It's just, that's my my understanding from following the people who study development.
Okay, thank you. Another question? In the white. Okay, I would like to ask you, Julia, about, you have presented a taxonomy of products, the high-intensive products, and I was wondering if when you studied the relationship with the footprints across the different countries, you find that it's possible to establish a global policy, or I mean the role that the products play in the different countries in environmental and in social terms. is the same across the different countries, and the path to reducing inequality has a similar pattern in the different regions in the world?
Yeah, so that was one of the things that we were surprised about. I think we were expecting to see more variation, and I showed you the probability density functions. I mean, there is quite a bit of variation, but obviously one of the things, you know, if you do input-output, you never trust one number, right? One number can be pretty crazy. So so that's why we sort of looked at these envelopes and sort of went with the middle of the envelope, because you know that transportation is well represented in household surveys, like personal transportation, paying for public transportation as well in some cases. I mean, even that is a bit weird sometimes, but everybody knows that transportation energy is rubbish in input-output. Like, because you have all of these things, it's not a sector, there's captive fleets within sectors. I mean, it's kind of a mess. So, but given all of that, one of the things that we could see is that given these probability densities that we could see, that indeed most countries did sort of fit a general picture where that was the case, where the richest people spend more money on transport and it's very energy intensive, and poor people don't. I mean, that's when people can save, they save on transport if possible. The other thing is that we see across the world is that sorry, my neighbors seem to think it's time to zoom around, is that poor households are trapped in energy inefficient ways of using energy. And that's especially true in developing countries. So for instance, in Zambia, but I think also in Nepal, the 50 percentile poorest households all consume the same energy per capita. And let me tell you that the 10th percentile and the 50th percentile have very different incomes. But they're still spending the same, they're still using the same amount of energy because they have no choice. They don't have access to efficient conversion technologies or to electricity, which would allow them to do things completely differently. So it's really, so I think that there's a lot there's a huge amount of potential to make people's lives better if we focus on, for a development perspective, to focus on energy within the home. Yeah. We also, in terms of the political economy studies we did, we looked at mainly at the transportation sector, and we've discovered some really incredible things about the way that the automotive industry creates car dependence and markets cars and creates car culture and all of that stuff. But that's a different story. That's maybe anyway. But that's also interesting.
Thank you. More questions?
Muy bien, salta un momento, Gallo, que estamos acabando.
I see here a hand. Yolanda. No, Yolanda, you're mute.
You're mute.
Sorry. So I was wondering, since transportation plays such a huge role, and during the COVID, like the most of air transportation was closed, do you have like estimation of the impact on the reduction of these footprints to have like a bigger estimation later?
I'm not sure I quite understood the question. So for COVID in general, we know that last year emissions globally dropped by something like 6.5%. And for transportation in the short term, I remember seeing some absolutely dramatic results for Europe, like within, a week or two of lockdown, 25 or 30% of transportation, emissions were down. In the UK, they said they didn't have to work on clean air zones anymore because the air was cleaned up in Leeds, for instance, which is not. I mean, obviously now it's back to even worse. And but then there was a counter phenomenon as well. So that didn't stay because I think people started being scared of public transportation and of shared spaces. So the people who had to go to work started driving. So so I think that also changed partway through the pandemic. And people just started driving to work instead of taking public transportation. So yeah, so I don't know if that was your question.
Yeah, it was more or less using that numbers to do a simulation to be how it will be if we keep this kind. I mean, how the footprint will be reduced if in the future we'll be able to reduce, I mean, hopefully not as much.
Yeah.
but
That's the kind of thing we did in Joel Millward Hopkins' model. So in this model of decent living energy, we basically dialed the transportation. We gave people access to, you know, hundreds of person kilometers per year, but we said if you live in the city, you'll do it via public transportation. And if you live in the countryside, then maybe you'll have access to a vehicle, but maybe it'll be an efficient vehicle or an electric vehicle or whatever. So we were able to sort of dial these things, and you can, and that's one of the things you can do. And you can in fact model it with input output. So exactly like you said, say how many person kilometers do you have? What is the mode going to be? How is it distributed? I mean, all of these things can be modeled, and it's really quite interesting and fun to look at. So we did a how low can you go model, but you could do any kind of thing in the middle.
Okay, thank you.
Okay. We have time for one question, two questions.
I feel like I disappointed people by not including enough like real IO maths. I thought that that it would be more fun if I talked about Aristotle and stuff, but maybe that was too far out. So
maybe I can raise the hand. Okay, Julia, and what do you think about the role of multinational corporations in this picture you are trying to depict?
yeah, absolutely. So I think that that's something that I really try to avoid. So, and it's something that it's a criticism I've had of my colleagues who do, you know, consumption-based accounting, which is that it's not because you do consumption-based accounting that the consumer is the problem, or that the only realm of action is consumer behavior, and that you have to change preferences or utility functions. So, when we look at these provisioning systems, we actually adopt a political economy approach called systems of provision, which is from heterodox economics and political economics, and we're basically looking at how things are produced, how production influences consumption. And we really see that happen. I mean, so we have this paper on car dependency, if you're interested in that, where you really see these corporations sort of evolving over time, ganging up with each other, you know, between the road industry and the car industry, and ganging up with land use planning with the real estate industry. And they really create, you know, they've created our cities, they've created our surroundings in such a way that we have to use their products. And they've also convinced our governments to neglect funding for public transportation. You know, so you really see that sort of established over time. And they've changed our culture. They changed the way we think about freedom. They changed the way we think about comfort. You know, they've really shaped our world. And we've been, one of my postdocs is right now, he's finishing a paper looking at the development of SUVization. So that more and more cars, so in Europe, transportation emissions are the ones that are going up. Europe would be doing so much better if it weren't for the fact that over the last 10 years, people have started driving more heavy and polluting cars. So SUVs by themselves are now the second source after electricity for carbon emissions increase. It's just stupid. Like, they're doing the same thing as normal sized cars, but worse. So and so he's studying that, and it really has to do with the industry pushing it for profit motive on the customers, using finance as a mechanism to keep people trapped in consumption patterns. So it is corporations. You can really see how corporations are certainly influencing consumption. It's not because people are doing the consuming that they have the choice about it necessarily. So that's, I think that was very important for me to be able to study both of those things.
Thank you.
But not with input output. That's more of a qualitative political economy perspective.
Okay.
Okay, so that's all. Thank you very much, Julia, again for your kind willingness to be here today. And thank you to all the participants. Just to finish, have a very nice and healthy summer, and see you in September in the next webinar this season. Okay.
Okay. Thank you, Julia.
Enjoy.
Thank you, Rosa. Bye bye.
Thank you. Bye bye.
Bye bye.